In the early 1990s, NASA initiated the Discovery program, which was intended to be a series of low-cost scientific missions. In 1996, the program's study team proposed a high-priority mission to explore the asteroid belt, using a spacecraft with an ion engine. Funding remained problematic for nearly a decade, but by 2004 the Dawn vehicle passed its critical design review. Dawn, the first space mission to visit either Vesta or Ceres, was launched on 27 September 2007. On 3 May 2011, Dawn acquired its first targeting image 1,200,000 kilometers, 750,000 miles, from Vesta. After orbiting Vesta for 13 months, Dawn used its ion engine to depart for Ceres, with gravitational capture occurring on 6 March 2015 at a separation of 61,000 kilometers, 38,000 miles. 4 months before the New Horizons flyby of Pluto, the spacecraft instrumentation included a framing camera, a visual and infrared spectrometer, and a gamma-ray and neutron detector. These instruments examined Ceres' shape and elemental composition. On 13 January 2015, as Dawn approached Ceres, the spacecraft took its first images at near Hubble resolution, revealing impact craters and a small high-albedo spot on the surface. Additional imaging sessions, at increasingly better resolution, took place from February to April. Dawn's mission profile called for it to study Ceres from a series of circular polar orbits at successively lower altitudes. It entered its first observational orbit, RC3, around Ceres at an altitude of 13,500 kilometers, 8,400 miles, on 23 April 2015, staying for only one orbit, 15 days. The spacecraft then reduced its orbital distance to 4,400 kilometers, 2,700 miles, for its second observational orbit, survey, for 3 weeks, then down to 1,470 kilometers, 910 miles, HAMO, high-altitude mapping orbit, for 2 months, and then down to its final orbit at 375 kilometers, 233 miles, LAMO, low-altitude mapping orbit, for at least 3 months. In October 2015, NASA released a true color portrait of Ceres made by Dawn. In 2017, Dawn's mission was extended to perform a series of closer orbits around Ceres until the hydrazine used to maintain its orbit ran out. Dawn soon discovered evidence of cryovolcanism, 2 distinct bright spots, or high albedo features, inside a crater, different from the bright spots observed in earlier Hubble images, were seen in a 19 February 2015 image, leading to speculation about a possible cryovolcanic origin or outgassing. On 2 September 2016, scientists from the Dawn team argued in a science paper that Ahuna Mons was the strongest evidence yet for cryovolcanic features on Ceres. On the 11th of May 2015, NASA released a higher resolution image showing that the spots were composed of multiple smaller spots. On the 9th of December 2015, NASA scientists reported that the bright spots on Ceres may be related to a type of salt, particularly a form of brine containing magnesium sulfate hexahydrate, magnesium sulfate 6H2O. The spots were also found to be associated with ammonia-rich clays. In June 2016, near-infrared spectra of these bright areas were found to be consistent with a large amount of sodium carbonate, Na2CO3, implying that recent geologic activity was probably involved in the creation of the bright spots. From June to October 2018, Dawn orbited Ceres from as close as 35 kilometers, 22 miles, to as far away as 4,000 kilometers, 2,500 miles. The Dawn mission ended on 1 November 2018 after the spacecraft ran out of fuel.